Hello, welcome everyone. This is the plan for today. We will talk about robotic vision for vehicles. And the last one, we will talk about the syllabus and talk about the plan for the entire semester. This is myself and my research. I did my PhD in UMass Boston, major in computer science from 2008 to 13. And then I did a postdoc for 3 years in CSAIL MIT. And some people actually ask me why you want to come back to Taiwan, and I would like to share something with you. Okay, so this is a media press in October last year. Our president, Dr. Zhang Maozhong, he got some funding for junior faculties.
他呢，主要的呢，这个研究呢是在这个 robotics 这个方面，我们也请像这个学生来讲看，
谢谢
他的感言。
谢谢校长。诚如校长说的，我其实有5年的时间，博士班，还有3年在 MIT 的 postdoc， 总共其实是8年的时间在 Boston。那 Boston 其实对我来说有点像是第2个家这样子。但是人在国外一段时间久了，就会开始想Where is my root？ 那刚好就是人生走到一个阶段，突然有一扇门开了，那我就回到台湾这样子。那回到台湾有3个主要的原因，第一个当然就是我的家人。那第2个是过去这个8年，我感受到台湾非常非常的不一样，就是有很大的变化。那其实这个我也刚好在 Boston 有机会就有见过陈次长，对，那陈次长那时候是到 Boston 给我们一个 talk， 那时候我有去，对，然后那时候陈次长就告诉我们台湾现在的变化是什么，也给我们非常非常大的鼓励这样子，对，那我就引用陈次长的，就是台湾的学生需要胆识和视野。那我希望我能够把这个带回台湾。那我的研究领域是在机器人。那我就先讲，就是说，我觉得台湾未来的10年，机器人非常重要。为什么呢？就是台湾的老年化非常的严重，那伴随着就是劳力的短缺。这时候机器人跟人工智慧刚好就补进这个缺口。那我们的工厂会需要智慧的机器人，例如说可以自动的搬运、自动的手臂可以做一些事情。那我们的农村也需要机器人，因为劳力的短缺。我们会需要机器人帮助我们做农务的事情，我们的老人家也需要机器人。老人家不管是在生理上或是心理上的照护，或甚至是陪伴，都需要机器人。那所以我认为这个是非常重要的。那我觉得我很幸运，在 MIT 我可以到这个算是全世界最顶尖的机器人实验室。那我从我之前的老板指导教授，我觉得我学到的是他们的一个视野。好，那我就引述我前老板Seth Taylor 的一段话，他是说research 有4个不同的阶段 ，from impossible to possible，from possible to usable，from usable to affordable。在这边我也很高兴，就是联发科愿意能够将无条件的 support 我们，让我们可以做这样的 frontier research，from impossible to possible。对，这是我非常感谢的。那最后我也相信在延揽人才方面，我也很高兴有张校长，他现在在交大要成立前瞻机器人实验室。那这个前瞻机器人实验室，我相信可以让延揽更多国外优秀的学子，这个是非常非常重要的事情。
To summarize, we have people come here to learn about, in general, like robotic vision application, SLAM, maybe virtual reality, or some simulation. Maybe deep learning. So we will actually cover many of the topics in this class. I would like to introduce you the Ducky Tongue. So some people come here also want to learn about ROS and how to use ROS to integrate in your research or in your applications. Actually, Ducky Tongue was initiated in 2015. And back to 2015, I was still in MIT, and I actually found some of my colleagues, they tried to put something together to have a course in MIT, and I found that the topic here are very interesting, and especially that the camera is the only sensor for the vehicle. So that's perfect for our robotic vision. So I joined the group in November, just about 2 or 3 months before I came back to Taiwan. Actually, we have the first Ducky Tongue internationally in NCTU. So we get started with like some robot setup to get the hardware ready. And by that time, some of the parts cannot be found in Taiwan, so we actually ship it from US. And do some 3D printing. And try to do some soldering together. And after the hardware is ready, we need to do some calibration for the camera. By the end of the class, everyone needs to learn how to run the lane following. Try to put the DocuBot in autonomous mode. So this is like a midnight sometime last year, and that's the first successful lane following. And some of the team want to do like a grass eater. It's more like a mole robot. Also see in the video, we are the first branch of the DocuTang. Actually, by now, there are more and more universities in the world, they start to use DocuTang. Now we have 9 universities in Europe, in US, and also in Asia. So I think sooner there will be more and more universities who use DocuTang in their course. This is actually the second semester of DocuTang. The second semester, the course is for junior year. So we actually want to do something about it to simplify the material from graduate level to undergrad. The good thing is that we have many of the OCW ready. So we will have some decent material for ROS or for Jupyter Notebook that will help you to know the code much better. We also provide some essential functionality like OpenCV for object recognition or finite state machine, and some basic motion planning or motion capturing. That was also a project-based learning. You can see this diagram, it looks pretty complicated. This is actually ROS diagram, the system architecture for the DocuBot. For example, if we want to do a task like lane following, we need to use many of the components at the same time. So first of all, we need a camera node to get the camera input, and the node will keep running. And the next step, a lane detector node will try to subscribe the incoming image and try to find the lines. Okay, so you can see like this, the yellow line and the white line. You can also see some curve, right? So the line detector is responsible to do this image processing and get those lines for the next node. And the length filter is actually try to do some voting in order to get like a lateral distance from the lane, like how much you are deviating in the lane, and also the heading of your vehicle. Next step, finite statement. For example, you can see in the Ducky Town video, so sometimes there are red lines, like to stop at the intersection, and you need to do something to control the state of the vehicle. So maybe at the intersection, the vehicle should do something differently from the lanes. Finally, Dagu car, that the node try to receive the wheel command and actually drive the motors. And we also have some simplified material for doing the test. So whenever you write some code, a good test will be necessary for a decent software engineering. And RVs is a visualization tool you can see on the bottom right. So it can actually show the world, show the Ducky Town, or show the vehicle. And the Jupyter Notebook, we think this is probably the easiest, well, I can say the most useful tool we can imagine for now. So essentially, you just put some Python code in the cell and just run it. You can interact with the code immediately. You can see the image and you can see what's the output. For example, if you do a canning edge detection. So actually, we will talk more about this later. And the good news is that many of the materials has been released, especially for our students. We already prepared those OCW material for you. And for the essential functionalities, I think someone talked about doing face detector. So we actually also cover some of the topics here. For example, detecting a face or detecting like a circle pattern or something else. And you definitely want to design your finite state machine to do something very cool about your robot. The vehicle starts with lane following, and when it sees the red line, switch to a coordination mode and turn right, and then back to lane following. Okay, see the stop line again, and this time turn left. We also design a state called yellow only. So for some scenario, for example, in a more realistic environment, we wish that this is a super ducky bot with a stronger motor. And you wish the robot can just follow a line in a realistic environment. And this is another functionality called motion capturing. So essentially, we just use the Apple tag, put it on top of a ducky bot, and there are also some like reference Apple tags. Okay, and this is actually done by a multiple system. Like there are some like mocap unit taken from the top. And you can also see the visualization on the right. Okay. And this is another project highlight, and try to add a gripper on a ducky bot. Okay. And the goal is to find a badminton in the environment. So again, this project integrates the motion capturing and also do some object detection, try to recognize the target and grab it and bring it back home. So we have an index of the OCW over here, okay, and we will come back to this pretty soon. And this is actually what we want to do for the semester. How we can see the OCW or all the materials, they are ready for you. And we wish that we can use them as a foundation, just like the center part of the class. And you can do something more about it. Okay, you can bring your research, you can work on an interesting project. So on the top left, that's probably more about some advanced robotic vision topics. Okay, Top right, that's something about 3D point cloud processing, and maybe also something about SLAM. And the bottom left, that's about deep learning. And the bottom right, we call it the cyber physical system, including some simulation like Gazebo or virtual reality or Unity, something like that. So essentially, we will have 4 major directions building on top of the Dakitan and RAS. Okay, and we will focus on the perception part of the robot. So actually, for many different applications, for the humanoid robot, for a robotic dog, or for a self-driving car or other robots, actually perception is the key. Maybe you have seen some of the sensors: sonar, 2D LiDAR, 3D LiDAR, stereo camera, or RGBD camera. And you can see some of the data you can get from those sensors. So this is a picture taken in 2013. And actually, there are lots of sensors in this picture. You can see a bicycle, right? That was me holding something. So what kind of sensor you can see in this picture? Laser rangefinder. Actually, there are a few sensors. Like there is a stereo camera, LiDAR, a laser rangefinder. And this is actually a robotic head. And there is another LiDAR sensor here and a RGBD camera over here. The robotic head is actually this one. Exactly the same head used in the DARPA Robotic Challenge. There is a stereo camera over here. It's also a 2D LiDAR rangefinder, but it can actually spin so that 2D becomes 3D. So that's actually the DRC competition used the sensor over here. And for the bicycle, actually there is another LiDAR over here, and a camera, and some haptic feedback on the handles. Okay, and actually there is a story behind this bicycle. It's called Blindcycle. Essentially, that's the bicycle for a blind person. The story was that there was a client. He lost his sight about 12 years old. I don't know how many people ride a bicycle here. Some of you, right? You have no idea how much people in US, they love bicycle. Okay. But the client, when he loses his sight, he cannot ride the bicycle anymore. So the team developed Blindcycle and tried to put the sensors and the feedback on the bicycle. Okay, so he can actually ride the bicycle in the track, not in the road, but somewhere safer. This is another LiDAR, and it is actually mounted in front of a user, and the application is to do the mapping inside the indoor environment. After we have the sensing, we actually need some computation to process those sensor data. So maybe something you process the data on board in an embedded computer, or it could be in a workstation or a server in a data center. And some of them are equipped with the GPU because the GPU has been very popular for the vision test. Textbooks, we will use this is a famous computer vision textbook available online. And you could probably find this in a library or ask the TA. And this is another robotic textbook available online. We will actually cover some fundamental and some advanced topic here. And we will cover the pulse, the trajectory, and the map. And we will also deal with some low-level image processing, and some filter and Hopf transform, some image features, for example, the famous SIFT feature or something else. And we will also talk about some of the object or text detection and recognition methods. Okay, so you may be wondering, is this computer vision or image processing courses? The answer is yes and no. And we will cover the fundamental, but actually we will focus on the real world problem, especially the image captured from a moving camera. And the good news is that many of the topics is in the OCW. So you can just watch the OCW, and then we can talk something more in the class or do some discussion in the class. So you can see some of the example. If we have the LiDAR, the laser rangefinder, and you can actually build a map in the indoor environment. So that's like a basic scan matcher, and it will use some like numerical method or maybe some like Hopf transform. This is a competition. It happened in Singapore 2 years ago. So the task is to recognize the symbol on the placard, like just a circle, triangle, and the cross. And you may think that this problem is like maybe too simple for you. But actually, in the real world scenario, the light condition could be different, perspective transform, or even the winds will change the shape. It will make this problem pretty challenging. Another example is that we actually use Apple tag a lot. So good things is that the Apple tag it's very robust, and it actually has some segments detected first, and then detect a quad, like maybe a rectangle or maybe not exactly a rectangle. The best part is that you can find a relative pause between the camera and the detected Apple tag. Because we are not able to afford you the real Atlas robot, right-hand side, actually it's $2 million US. Right, so we cannot afford you $2 million to buy this robot and maintain the robot in NCTU, but we have Gazebo. Yeah, you can actually control the robot exactly the same way, like control a real robot. You know, in the simulation now, the good thing is that the real robot and the robot in simulation could give you the same sensor data, and you can process those sensor data and send your command back to either real robot or simulated robot. The platform is actually quite mature now. In fact, in the competition, the first stage is actually use Gazebo. So there were more than 100 teams in the world participating in the competition. There was no team from Taiwan, so we should build a team, right? All right, so the schedule, we will send the detail of the schedule to you shortly. And sorry, this is probably a little bit small, but well, and we actually have the lectures here, and it will cover some basic or some like some advanced topic. You can see Apple tag over here. And you can see relevant OCW material. And we also have in-class tutorials. Okay. And this part is blank for now because we will find our students who fill this in. Okay. So this is the class organization. In class, that's in these 3 hours, I wish we can use the most of it. And the first part, I will cover the lectures. And the second part, it will be in-class tutorials workshop by all students. I actually like this kind of organization, use this class time. It is not just a professor keep talking, and then, you know, in that case, you can just watch a video. You don't need a professor here, right? You come here to have the discussion, to work with your teammates, to learn from each other. Okay, this is actually what I hope for a graduate level class. And you may hear about like 翻转教育, right? Then even some class there is no lecture at all. All the videos are online, and you can watch the OCW, and then you ask questions during this in-class section. Okay, but we will just still have the lecture for the first part. I will be here in the in-class section for sure. Second part is the OCW. I wish that we can have 9 hours commitment a week for this class. 9 hours includes the in-class section. So that would be another 6 hours from you. In this 6 hours, you can watch the OCW, you have the hand-on play with the ducky bot or coding. Let me emphasize this. I encourage everyone to not work for the minimum. Some people say, oh, I want to pass something and I just do my minimum in order to get a CP 值的，你们大概知道 CP 值很高。But in this class, I definitely don't want something like that. Okay, I would wish that you just schedule your time, maybe just 3 hours a week, and you make the most of it in the 3 hours. I won't ask additional time from you. Okay, so this is another thing. I wish that everyone in the team and we should contribute 9 hours a week, including the in-class section. And the grading policy, each team will cover one of the tutorials. Okay, that will take 20%. So that's kind of important in this class. The good news is that you can decide your topic. So we will talk about what we wish you to present shortly. And we have assignment 10%, final presentation, project, and the paper, and the class participation, and some bonus. Each section will be led by a team, so you are not working alone. You don't need to do this all by yourself. You have your teammates. I think it's kind of flexible. So it could be some essential functionalities in about robotic vision. If you know like some tools that is very useful for robotic vision, or you're already using it and you can share with it with your classmates, okay? And it could be a software package in Dockytown or ROS. So if someone wants to maybe do ROS and integrate the navigation stack, I think that would be a great topic for robotic vision. Okay, and all you need to do just maybe sudo apt-get and maybe ROS indigo, blah, 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 and you get it installed, right? And you can share with how to use it in the class. I think that's also a good topic. And also some algorithm in research paper. I think many of the papers in robotic vision or robotic community, they also publish their source code. Okay, so if you want to just show us what's the algorithm and run the code and to some demo to run the code, that would be a great tutorial. From my past experience, I found that assignment is still the most efficient way to help students to get started. The assignment is try to run Jupyter Notebook, and then we will just want to grade it as a pass or fail. Okay, so as long as we can see that you put enough efforts and try to get familiar with the tools, we will gracefully give you the points. In addition to the tutorials, then the objective of this course, by the end of the semester, you have something that you are proud of. You have something exciting, right? You have something you want to put in your CV. You want something to impress other people, not just a number, right? That's something you want to do in the class. Yeah, the good thing is that you are encouraged to bring relevant projects from your research. You can also continue with the tutorial. For example, you want to do navigation in the ROS stack. And if you have your own data, you can apply your data to those tools and figure out a useful application. Then I think that's also a good project. Because most of you are graduate students. Maybe you write something about a research report in your course. But I hope that this course will help you to build some foundation of writing a research paper. So this is like essential sections in a research paper. And I wish that you could take this as a foundation and later on publish the paper in our top conference to show the world. For example, in the ICRA, in IRAS, or in RSS, some of the best conference in our robotic community. And actually, Ducky Tongue was published in ICRAN this year in Singapore. All the slides will be in English, and term papers should be in English. But QA, I would definitely want to encourage you to communicate. So if you feel more comfortable to speak out in Mandarin, I'm fine with that. If you don't have further question, then that's about it for today.